You're listening to World Oil Deep Dive, conversations with energy industry leaders and engineers about the market trends and technologies shaping the oil and gas industry. Now, here's this week's episode.
Well, greetings, everyone, and welcome to another session of World Oil's Deep Dive podcast. In this episode, we're talking with Will Kernan, Oil and Gas Strategy Manager at Caterpillar. I'm Kurt Abraham, Editor-in-Chief of World Oil, moderating this session. The oil and gas industry is facing an unprecedented challenge. The electrical grid cannot keep pace with its soaring power demands. As drilling operations expand and electrification accelerates, grid capacity in key regions like the Permian Basin is being stretched to its limits. This imbalance threatens production timelines, operational reliability, and long-term growth. So in this episode, as we sit down with Caterpillar to explore why power demand is outstripping supply, we'll look at the implications for oil and gas companies and the strategies being deployed to bridge the gap. From leveraging natural gas for on-site generation to navigating competition with other industries, we'll uncover practical solutions and future outlooks. Join us as we discuss how companies can secure resilient power infrastructure and maintain momentum in an increasingly energy-constrained environment. So with all of that, Will, welcome to the podcast, and let's just dive right into it. What's causing power demand, in your opinion, to outstrip the grid capacity?
Yeah, well, first, let me say, Kurt, thanks for having me. Excited to be here. As this is it is definitely a pressing topic that I think everyone's becoming more and more aware is becoming a bigger and bigger problem as we kind of keep as things keep developing out in the oil and gas industry. To your first question of like, why is this becoming such, a big problem? It's a combination of a couple things. First, I think is starting from, the oil field is continuing to electrify, right? We're continuing to have production increase. Both liquids and gas are not expected to peak until sometime in the 2030s, depending on which one you're talking about. And with that, we're continuing to see more and more demand, more need for, technologies like electric compression or even pump jacks, ESPs, all these different types of processes that need more and more power. And so while the oil field is naturally consuming more power, we're also seeing pressure from other industries, right? AI and data centers are obviously the hot topic of the day, which while, if we want to focus on just oil and gas, aren't entirely related to us. But when we look at where do people normally get their power from, it's just the utility grid. We can't look at ourselves in a vacuum in that sense, right? Where all of a sudden other industries now are starting to put pressure or competition, if you will, for that utility power. And those two things are really what's coming together to create, I'll say, a supply constraint where oil field is looking for more power, and we're now also having more competition to get that power. And then, of course, I guess you could say maybe the third leg of this is, the utility takes time and is slow to respond. So they can't just, start up new power plants at the levels we're talking about it.
Sure. So on that note, what are your latest projections and how is this especially affecting the Permian?
Yeah, so the projections, ERCOT does, I would say, a pretty good job. They do release a Permian Basin power study every so often. And I mean, currently, a lot of their projections say that there's between 4 to 5 gigawatts worth of power being used in the Permian Basin today, with a lot of their longer term projections pushing that up to around, call it 15 to 17 gigawatts worth of power. So over the next 10 years or so, you're basically looking at a tripling of that amount of power being used, which again, and it's that context, ERCOT as an entire utility grid today is about 90 gigawatts. So adding an additional call it 10 gigawatts of power, it's not it's not nothing, but it's a very manageable addition, especially over this time frame. It's when you add in all the data centers and obviously, other, residential growth and other industry growth like that as well, is where then now you see ERCOT's current projections today is a 90 gigawatt load, and they're forecasting by 2030 they need to have almost 150 gigawatts. So it's kind of one of those, you can see there's a tale of two stories in that, where oil and gas is contributing to it, but it's really pressures coming from other places. It's why oil and gas is having to start to look at other solutions, as ways to power our operations without being, I'll say, impacted by utility constraints.
So, tapping into your expertise on all this, how do you think oil and gas companies can manage the competition for the electricity?
Yeah, it's managing that is, I think there's the number one way I think that a lot of people are saying, and oil and gas is uniquely positioned in this regard, is we can actually take that our electricity generation into our own hands, right? A lot of times in a lot of other industries, right, don't have, as the name implies, a lot of natural gas readily available, which, is natural gas is the predominant fuel source for the entire United States. And, when you look at the Permian Basin, for example, one of the main constraints that it has is takeaway capacity, right? Every single time a new pipeline opens up, it is almost instantly booked and full. And we are only going to see that continue to be a challenge with LNG exports continuing to expand and grow in the coming years. So we're in a unique position that we have an abundance of a fuel source and yet also a constraint on power. These two naturally align themselves to saying, how do we build some type of infield generation or a distributed power generation type design, where there's a lot of different technologies out there, a lot of different engines, turbines being the two predominant ones everyone likes to talk about. But how do you take that, again, cheap fuel and convert it to that energy in a, I'll say economical, but also practical way that works for operations? I mean, that's really the challenge I think a lot of people are struggling with today, is how to make that jump into managing their own electricity.
Indeed. And how do you think the growing LNG industry is impacting the ability of the oil and gas companies to tap into natural gas and close the power gap for themselves somewhat?
It's kind of, I feel like the LNG, it's kind of a funny double-edged sword in this regard, right? That with, you know, exporting LNG, it's got one element, which is I'll say you don't want to burn the gas for power generation, right? Because you're trying to export it. But at the same time, we're drastically driving up, the power demand to do that, right? We need more compression power. We need more processing power. And at the same time, as I mentioned earlier, we're still driving up those production numbers to supply all that additional LNG for exporting while also still meeting domestic power needs. So it's kind of a back and forth that the LNG is going to drive, I'll say, drive the need for more power, while at the same time, like we were talking, the utility is going to, let's be optimistic and say, it's going to do its best to try and meet our power demand, but we know there's going to be challenges. So how do you kind of walk that balance of increasing your power demand, export a product you want to, being LNG, while also continuing to say, how do I use this or the excess of this for my power generation?
Sure. Another thought that comes to mind is how are the oil and gas companies going to shore up their power supply to ensure their operations aren't interrupted? There's a lot of concern about that.
Yeah, and that is, we're talking a lot or have mentioned a whole bunch about, getting the utility. There are some concerns of exactly like what you mentioned of that. Well, even if you have a utility connection, is it reliable? Is it going to be stable? Or are you going to be subject to forced blackouts during the summer, right? There's a lot of concerns around that space, and I think that is playing into some of the decisions that Do you put some type of on-site power generation to add resilience to your operations, right? Even if you have the utility, do you have backup generators or some level of power generation that can reduce your load on a grid, right? To give you, call it that operational flexibility. It also can introduce your ability to, I'll say, optimize your operations, where you can work to, at some parts of the year, the utility grid will be the cheapest electricity that you can get. Oftentimes during the winter months, right, where there's just not as much load on the grid. But come summer months, when we get those really high peak demand hours, your power generation could arguably be cheaper than the utility grid at that point. So there's multiple avenues that I think you can, as you said, shore up your operations in this front. But it is I'll say difficult, because there's no one solution fits all. You really have to kind of take a look at what are your project needs, what are your loads that you're experiencing, and try to figure out what's the right solution for you.
Sure. This next one may be kind of a no-brainer, but I need to ask it anyway. Do you
Mm-hmm.
think regulatory or permitting delays are contributing to the grid's inability to scale quickly?
It's always a little hard to see exactly where all those permits and stuff are hung up at. But by and large, I think it's definitely not doing us, it's not doing us any favors in that regard. Um, if Although I would say, when I look at where the, call it, the bottlenecks are, and in those, especially when we say that we're talking the utility grid, right? With the utility, we're talking large grid scale power plants. Um, the real challenge around those is around just getting all the equipment. I mean, those are massive construction projects to get, you know, plants that are gigawatts in size up and running. So they simply have a really long lead time. And I think that's what does lead to, um, and that's in addition to once you do get permitted, right? So there's kind of both sides of that equation of the getting the project going with permitting is a challenge. But then even once you are permitted, you're still talking a long lead time to before the electricity starts flowing. I think that does help our the oil and gas side of things, in the regard of when we talk about, again, like microgrids or distributed power generation. Um, those can be implemented much faster, right? So it kind of starts to play into a little bit what we were saying earlier with your, how shall I say, taking that in your electricity into your own hands, of saying, hey, I can build my own microgrid faster than the utility can get here, and I then can manage costs and much more predictably than the utility grid.
Sure. Um, what technologies or innovations, in your opinion, are starting to emerge that would help the oil and gas firms become more energy self-sufficient?
Hmm. I think the probably some of there's a couple that come to mind. I would say, first, you know, coming from the engine side of things, right? We see two predominant technologies when we talk power generation, right? We have recip generators and turbines. Um, and traditionally, especially in the power gen side of the space, they were very much a, pick and choose what you were, what performance you were after. And you kind of had to sacrifice a lot of other elements for it. In the context of oil field applications, high efficiency, right? That's obviously something everyone cares about in their generator. But usually, the traditional, let's say, cons of high efficiency generators is, they can't do transient applications, which makes them potentially a poor fit for microgrids or things where they don't have utility support, and also fuel flexibility. We have a lot of different types of gas supplies in the oil field that could really cause performance problems for generators. Uh, as we see newer engines come out, like the Caterpillar G3520K that was recently released, that's really starting to see where we see these technology or these engine platforms not compromising, where we can still bring a high efficiency, 46% efficient genset, while also bringing some fuel flexibility and transient capability that could make this engine much more flexible and applicable to an oil field application. Um, so it's a interesting of, we used to have to compromise basically, and now we're starting to see with this type of demand and this focus, what solutions can be brought to market that don't compromise, right? You know, with while also maximizing operational, not requiring expensive battery systems unless they're absolutely necessary, things like that.
Understood. Do you think that microgrids or hybrid power systems could be a viable long-term solution for some of the remote operations?
Oh, absolutely. I think not only are they potentially going to be, I think they already are starting to be. The microgrid solutions, I think the real question is what's the scale of them going to be, right? Micro solutions call it in the scale of five, if you really want to think about a small microgrid, drill rigs or e-frac fleets are small microgrids, and they've been in use for drilling decades, and e-frac call it for the last five years or so. I think what's changing now is that long-term vision. When we talk those service type industries, they're mobile, they're moving. It's kind of it's an operation. Whereas now we're shifting towards the more, production side of the industry, where all of a sudden you're now not looking at a frac fleet that's on site for, it's bringing 20 megawatts or 30 megawatts on site for a couple of weeks. You're now looking at a small microgrid that's, say, 30 megawatts or 50 megawatts that's going to need to be there for the next 5 to 10 years. And that's kind of where I think the shift is, where a lot of the technology, and potential uses are going to change when you add that time component to it, right? All of a sudden, we were talking about efficiency earlier. You might care more about that efficiency. You're also going to have maybe slightly different installation requirements, right? Buildings, start to make sense, and what would be your solution then? But overall, I absolutely think, you're starting to see those microgrids take shape now, and they're only going to grow and expand and become more sophisticated as the industry, becomes more comfortable with them and learns how to build them and use them.
Yes, definitely. So, based on that, looking more at the financial side of things, because that always
hmm
enters into the discussion, how do you see power challenges shaping investment decisions in the next 5 to 10 years?
I think they will be one of the bigger factors that are going to continue to become be an influencer, right? I mean, even today, right? There's obviously a lot of investment that's being built into, if you want to take the other side of the sector, or the power question, how are you powering all these data centers? There's a lot of investment in that, but at the same time, we know that oil and gas, we are the ones providing the fuel for all of those data centers and everyone else's homes and everything. So how are you providing power for oil and gas is now going to become an investment decision. Again, when we were talking about building out microgrids, that's an excellent example of a long-term investment that if you're looking at, and building out an entire microgrid or something, you could be looking at, call it anywhere between, and obviously scales a lot with size and space and everything, but you're talking tens of millions of dollars. And if that tens of millions of dollars has an impact on an entire oil field's production, that's going to start to become a really important decision about how are we powering our operations? How are we making them more resilient? Where are we spending investment dollars into some type of self power generation, backup generation? There's a bunch of different avenues and technologies that have obviously a lot of different costs, can go up and down. But they're going to become very important in terms of, any investment, especially in the oil field, is now going to start to become attached with a question of how is this being powered? And does it require additional investment? Is it additional risk to the, call it, production investment? It's going to start to become, they're going to become interlinked. Basically, it would be my opinion.
I understand, and risk is always there. One final question.
Mhm.
How do you think companies are balancing their sustainability goals with the need for the reliable power?
I think it's definitely as you said, a balance, right? And I think it gets a little bit to kind of what we were saying earlier, that when we look at the technologies about getting reliable power, traditionally we would used to compromise in one of different ways and call it emissions, and sustainability might have been one of those. Well, now we're continuing to try and push that technology envelope to say, I don't want to. I need my reliable operations, but I don't want to compromise on sustainability, right? Now that can take a lot of different shapes in terms of what they're using or what the solutions shape up as. We mentioned earlier putting generators and utility at the same time to kind of maximize what's the optimal way to run their operations and achieve sustainability goals of reducing maybe their on-site generation while also having that reliability and resilience. Or, if they were doing more of a microgrid distributed power generation model, is there incorporation of battery energy storage systems, even the potential to incorporate renewables into these power generation systems, right? If you have a microgrid and the ability to control all that power, you start to get into these more complex microgrids where generators and other type of more sustainable solutions can definitely coexist and start to meet those goals. But it is definitely, again, I think we're seeing definitely a focus on that reliability, though, is definitely one of those. How do you can't compromise reliability and safety, right? And that's definitely kind of, I think, at the forefront for a lot of the oil and gas operators.
All right. Well, thanks so much, Will. Enjoyed this conversation very much. Folks, we're out of time for this episode. Thanks to Will Kernan for his great insight, and many thanks to all of you for listening.
Great. Thanks for having me, Kurt.
Thanks for tuning in to our show. Please check out the show notes for the links we discussed in the podcast. We value your opinions, so if you have any questions or comments, kindly email them to us at deepdive@worldoil.com. Additionally, we'd appreciate it if you could rate us on your preferred podcast listening app. Lastly, don't forget to visit worldoil.com for the latest technical articles and news about the oil and gas industry.